Hello guys, again, Delroy the Spark here. Um, just going back doing some remedial work on the job I done. This is a bit interesting. This job. What happened was just before the lockdown, I was supposed to come and do an EICR down here, but the lockdown came at the time when I was going to do it, and the people, about 5 people live in the place, and they all are working from home. So, you weren't supposed to go to people's houses. Although there was a bit of confusion. They said tradesmen could go. But anyway, the fact that they were working from home would prevent me from sort of being able to do the work properly, switching things off and stuff. It would disrupt their working. So it was agreed I would do it after when the lockdown was over. So when they relaxed it, I decided, yeah, I'll be able to do it. But remember, even though it's been relaxed, people are still working from home. So what I said, okay, then I'll do it on a Saturday over the weekends. That way I wouldn't disrupt their working patterns. And that's what I've been doing. I done the test, carried out the test. They wanted me to do the remedial work. There's quite a bit. And I worked here last Saturday, and I've just turned up to do it now. I don't know if any of you guys have had to do anything like that. It's not ideal because I don't usually work weekends, only in emergency. Somebody lost power or something, I might go out. But typically I wouldn't work at the weekend. But give it a go. I just thought I'd let you guys know about that. I don't know if you've been through the same experience. Let me know. This is the setup in the house. I'm in the basement. That's the stairs going up there. That's the sat with the fuse board. I'm going to change that fuse board. I'm going to put RCBOs in, a metal fuse board with RC. They got all big holes in the top of this fuse board here, and it's a bit rickety anyway. It's not that solid. So, and there's no RCD protection. So I'm gonna I'm going to put up a new 18th edition Amendment 3 fuse board there. And last week, what I did here, this is the main water pipe, and what you had here, this is a 16 mil. They had it, there wasn't no lug on it, it was just pushed on there, and then they ran a 2.5 from here over to here for the gas, right? So what I had to do, I took that out, put a lug on there. This was all loose as well, so I tightened that up, and then I ran a New Earth 10 mil over to the gas, brought it round over to the mains over here. But what I'm going to do, I'm going to put an isolating switch here, and then from here into there, so you can isolate. Because what happens is, when you come, sometimes you come to do work on a fuse board, and it's best if you have an isolating switch, so you can just switch it off, do your work, switch it back on. Don't have to mess about with the fuse or the meter or anything. So, and that's a good thing to have. Last week you can notice here, you've got these are 2 lighting circuits. They're bunched in there. What happened was, you got the kitchen lights that are on the ground floor, and the kitchen lights that are on the ground floor, and the top floor lights, and they were put together. So that's a bit weird. Anyway, eventually I'm going to separate them, and hopefully they'll work. But I have come across where they've been bunched like that, separated them, and then when you switch it on, it starts tripping the two, because somewhere in the circuit the neutrals were linked. So I just had to put them back together. This was on another job, obviously, years ago. I had to put them back together because I couldn't leave them. It just kept tripping. So hopefully these are just separate circuits that they've just linked together. It should be, because one's at the top of the house, one's at the ground floor, so it should be. When I done the EICR, this socket here, it's a 3-pin socket for lights, yeah. I was trying to do a loop test, but I couldn't get 240 volts. got in 130 something. So I come to see what the fault was. So this morning I took it off, tested it. I was getting 180 something volts. So went over here to the switch. There you are, sockets. All I done was done a bit of tightening up in here, tightened the live conductors, tightened the neutral and the earth, and then I came back over there and done my test, and that's my results. 0.55, which is good. It's worked out nicely because I was worried that it was going to be some rewiring problem. Okay, so that's all good. Hi guys, got an interesting little problem here. This is the lighting circuit for the first floor, and when I do a insulation resistance test, phasing neutral to earth, I'm getting 0, 0. Right now, that's giving you like there's a dead short fault there, yeah. But it's not been tripping. I had that when I done the ECR, so now I'm trying to find out what's causing it. But I had that when I done the ECR, tested it again, still getting zeros. So I went upstairs, there was a shaver point, disconnected the shaver point, came back and I tested it and I got 87 point something, which is a lot better. But then when I went to the shaver point and tested, there's 2 cables though, tested both cables, I was getting 0, 0 again. At that point, I would have thought that one would be 87 something and the other one would give me 0, 0. So it's a bit foxing. But the thing is, nothing's tripping. So it's not a proper short. There's something in the circuit that's causing it, but it's not bad enough to trip anything. So I've come across this before. But I didn't find out what it was. It's just the thing's working, not tripping. If it trips, then you find it out. But what I done, I came here, this is a shaver point, yeah? Disconnected the shaver point, you got 2 cables. So I separated them, twist live and neutral to earth on that side, and I got 0, 0, yeah? So then what I've done, disconnected this switch, yeah? Because what they've done, they brought the live and neutral to the switch and then over to the fan. Okay, anyway, and to the shaver. So what I've done, disconnected the switch and separated my feeds, yeah? Came back here and I'm going to test between live and neutral to earth, live and neutral earth. I'll have to just tell you the results because I can't really do it. Can't hold the camera while I'm doing it. So I'm going to do that and I'll get back to you. There guys, as you can see here, I've got 94.7 megohms. That's for this side, where previously I was getting 0.0 at both of them. But seeing that I've disconnected the lives at the switches outside, that's given me a good reading on this one. Let's see what I get on this one. There you go guys, tested the other one by phasing neutral to earth, and that's what I got, 0.0, yeah? So I'll just get on and see what I can find. But like I say, you've got that reading, but nothing trips. The circuit works perfectly. I'm just trying to see if I can figure out what's causing it. The circuit's working perfectly, but I wonder what would happen when I put when I put the circuit on an RCBO. It might trip then. So probably needs to get it sorted. What's happened now, over at the shaver point, I had 2 sets of cables. One was fine, the other one was giving me dead short. I traced that cable to here and isolated it from the rest. Phasing neutral to earth. Right, I'm going to pick up from where we left off. I was filming and rookie mistake, run out of space on the camera. So back on it now though. So where we left off, I was tracing a fault, if you can remember. I was tracing a fault. I was doing a insulation resistance test on the lighting circuit, the first floor lighting circuit, and I kept getting a dead short. Phase and neutral together, down to earth. I kept getting a dead short. So I thought, you've got a shaver, you've got an LED light, and you've got a fan. So it's one of those I would have thought that was causing the problem. But I couldn't figure out why you'd get a dead short. I always thought you put live and neutral down, live and neutral together, down to earth, test down to earth, you're going to get some sort of reading, not a dead short. But like I said, I've come across it before, but I never looked into it too deeply. This time I thought I'd try and figure out what was causing it. So I traced the fault to the shaver socket, then I chased it to the light switch over the in the hallway. So there's the shaver socket, LED light up there, and your fan there. So over here, what happened when the camera, I had to get on with the work. So there was a isolation switch here for the fan, and the client told me that he transferred it from here just to the switch, because he said they kept hitting the fan switch all the time. Usually you'd have the fan switch a bit higher up at the top here. You wouldn't have it there usually. That's how I do them anyway. So he just said he got fed up of it, so he just transferred it to the he done away with that and just fed it from the switch it on and off from the switch. So that's not against regulation. If I was, anytime I do a fan, I always put a 3-port switch, always put an isolation switch, but it's not against regulation if you don't have it. But when I was doing the testing, I noticed that the cables weren't in the box properly. It was a metal box, no grommets or anything. The cables were stretching a bit, so I had to take the box out, refigure the cables so they were in properly and no strain on it or anything like that, and refitted the box. So, and then I'd done the connections, put a blank plate there, because the switch was basically just a blank plate. So I put a proper blank plate. So when you switch on the light, switch it on, and then the fan. The funny thing about this fan, it doesn't kick in straight away. I noticed that from when I done the ERCR. See, it's on, but it hasn't clicked in straight away. Comes on eventually. So I don't know why that is. So eventually, I traced the fault. I traced what was causing the fault was the fan. The fan is causing the fault, which I don't completely understand, because I thought once you put phase and neutral together and insulation to earth, you would get a reading. But obviously, electronic stuff in the fan probably causes it not to give you a proper reading. I'll have to find that out. I'm not sure about that. When you're doing this sort of business, you know, you can't know everything. There's lots of stuff that you find out that, you know, you don't know before. But it's good. It's all good. You know, it's all good. It's good to come across problems. For these young sparkies out there, it's good to have problems, because once you solve the problem, you're better for it. You know, it's really good. So I'm going to get on with the rest of the work. Today, I'm trying to figure out how I'm going to fit this fuse board. Right, I've mounted my isolation switch, as you can see there, and connected back into the fuse board. This is just a temporary thing, because when you're doing these fuse board changes, you don't want to try and take on everything at once, because once you disconnect all the circuits and all that, you have to get it all back, because people are living here. You can't leave things off. So I learned the hard way. So I've set that up, and I'm just trying to figure. I've left the brown really long because the neutral is going to be short, so I'll have to change that. But I'm not sure where the fuse board is going to end up, so I don't want to leave the brown too short. So I've left it quite long, so I can cut it to the length I want. I'm going to have to change the neutral. I'm pretty sure of that, because as you can see, it's going to be a bit short. But like I said, it's just temporary. This, yeah. See, look at that. You think that's just a simple task to do that, but fitting that backboard, yeah, fitting that backboard. I'm drilling to yellow, those bricks are yellow stock, right? And sometimes you drill into them, they're quite soft. So when I done it, the screws, these screws kept turning. So I couldn't leave it like that. You got to get proper, you've got to get proper fixings. So what I had to do is I put the first one in, fixed it, try and put the other ones in, and a couple of them kept turning. So what I had to do, take the board off, and then I pushed the raw plug further in the wall and use longer screws, right? And using the longer screws and pushing the raw plug more in the wall, I got it tight. So I've got some nice firm fixings. The screws aren't turning. That's a solid thing. So I've come across so many times where things are just hanging off the wall. I mean, look at this, right? Now, I couldn't leave a fuse board like that. That's not me, man. It's got to be, I couldn't leave a fuse board like that. It's got to be fixed properly, right? So I don't think that's being a perfectionist. It's just doing things right, isn't it? I don't know. Tell me what you guys think. This is something that I noticed when I was doing the EICR, but it didn't really register. But having come back to do remedial work, it's registered a bit more. So you got the kitchen sink there, yeah? And then underneath, you've got these light fittings, yeah? See, I'm just thinking, is that right? Should you have that? I'm not sure if that's against regulations, but to me, it's near water, it's near the pipes. I just think probably if you was going to have a fit in there, I don't know, maybe an LED strip might be better. I'm not sure. I'll have to find out. Maybe you guys know. You can let me know. Bye. Yeah. Look, there's something else that I saw but didn't register. Was this? Look, that's a pendant outside the front door. That should be weatherproof. So I'm going to have to change that to a weatherproof fitting. I've got about 3 good fixings, decent fixings, but it's all plaster and lath. This is all plaster and lath, and I couldn't find a beam anywhere near to fix it to. So I tried plasterboard fixings, they just went right through. I got 1 good plasterboard fixing and another couple fixings to the lath. So it's up there. It's nice and sturdy. It's all good. There it is. Working conditions. It's on and off. All good. That's the second light I'm going to change. It's a batten holder. Look how near it is to the bath. Right. That's the bath rail here. Bath here. I'm standing on the floor and I can touch it. Yeah. I think if you're in the bath. So I'm going to change that to a IP enclosed fitting. There you go. This was another difficult one to do, but the ceiling's more solid. Ceiling's proper plasterboard, so I used 2 plasterboard fixings and got it. But the cables were short, so it's a bit tricky, but it's all done. All nice and sweet. I'm going to turn the power on now, see if it works. There you go, all working nice and properly, nice and good. Off. Right, you heard the pull switch there. It's not making good. I think I'm gonna have to change that. I just noticed that the other week, last week. It's not making properly, so I'll change that. Yeah, I managed to get those 2 fittings up. I didn't get to do much preparation for the fuse board, but coming back first thing tomorrow morning, jump on that and see how it goes. Yeah, them 2 fittings really gave me a bit of problems. Mostly it's the fixings and short cables. The one outside the door, I think the cables were keeping the fitting up. It was only a pendant. The cables were keeping it up because the 2 screws in there wasn't holding to anything. But it was hard to get fixings there, but yeah, I got some eventually. And the bathroom one, yeah, I had to use two plasterboard fixings. They work out, and that was really nice and tight because that was like proper plasterboard, so that was good. um I had to run back to the van because I run out of parking. And so I'm going to be off now, come back tomorrow and get on with it. Yeah, so for those younger sparkies, um you have to, when you're putting up stuff, you have to try and get good fixings, because when I go around, when I'm called out to fault finding and stuff like that, the fittings are always hanging by one screw or whatever, and then loose connections, burn the terminals out. Got to make sure you get stuff fitted properly. Sometimes you can't do it quick. Sometimes you just have to get it done. As long as you get it done properly, it's better in the long run. you know Really, what they should do, they should put a noggin above the ceiling wherever you're going to fit a fitting. They should put some sort of noggin there so you can fix to that, or put the fitting to the nearest joist. Yeah. You can do that, but you're going to cause a lot of damage. You don't want to do that when else the client's got to do a bit of plastering and all that. So anyway, all good. See you next time. I'm back here. I'm going to do this pull switch here. So I've took down the cover of the pull switch, and I'll show you. Look at all the cables there. Yeah, you got four feet in that side, and then you've got the switch line and the switch line for the fan in here, and you've got the neutrals in the back. It's quite a bit of cable for a small space like that in the pull switch. And outside they've got a isolation switch. If anything, they should have had more of the cables at the isolation switch. But just for the younger sparkies out there, when you're doing rewires like that, if you're putting this in, you want to make sure you've got least cables in somewhere like this. You don't want to bring all the cables at this position, because there's better ways to do it. Save you a lot of aggravation when it comes to connections. Okay, I'll get on with it, see how it goes. See all them cables at the pull switch? Aggravation, man. You shouldn't have done it. I wouldn't do it like that. I'd just have one set of cables there. Live switch line and earth, or live switch line and earth, and that's it. Not all those. Anyway, what I tried to do, I thought I could leave the base up and just screw a new switch to the base, but it wouldn't fit. Well, it would fit, but I drilled out these are the screws that come with the new one, and these are the screws that come with the old one. Slightly quite bigger. So I thought what I'd do, I thought, okay, then I'll drill out those holes to fit the old screws. So I drilled them out. Thought I could get away with it, but they go in, but it doesn't sit properly. It doesn't sit properly on the. It wouldn't look good. It would just look a bit. Just wouldn't look good. I wasn't satisfied with it. So in the end, I had to take it down, take the whole thing down and put a new one up. Hopefully, this is the new one. Hopefully, I can screw it up. I was worried about the fixings and that. Actually, they've put raw plugs in there. So hopefully I can get a nice fit with those raw plugs. They seem to fit tight, so should be okay. But with this, you see, with these type of ceilings, you don't want to mess about too much. Try messing about with them, you just give yourself a whole bag of trouble. Okay, so I'll get on, see how it goes. that pull switch isn't going too well. What it is, I got it up. There's 5 neutrals, 4 feeds, and 2 switch lines, and 5 earths or something like that. So I struggle to connect all the neutrals, because if I put one of those Wago, if I use a Wago, it's going to be too bulky to fit into the pull switch. So I used some connectors, and this, I used some connectors. and it's really stiff, the cable. To try and push it up to the back of the box was hard to do that. So connected the live and neutral, connected the switch line and all the feeds, forced them in, because to get 5 feeds into a pull switch terminal is not easy. So I done that, and somebody wanted to use the bath of all things. Oh my days. Anyway, so what I done, I just connected it temporary, because I said this isn't, I could to try and push the pull switch up, it wouldn't go up. You'd have to force it in, and I think that's what they probably done. That's why it's messed up the movement of the switch. So I've left it safe so they can use the bath. Once they're finished, I'm going to go back. But what I'm going to do, I'm going to use a junction box, connect the cables in a junction box, push it up in the ceiling, come out with just one set of cables, 3-core, phase neutral, switch line and earth, and that's it. That's the best I can do. I don't know how that's going to go, because I was trying to avoid that, because once you start messing about with these ceilings, there's a whole load of problems. But I'm going to have to do that, because I can't try and put it back the way it was, because it's just not right. Also, this is the type of connector they used for the neutral. It's just them clear plastic ones. Now, I never use these for the neutral or the phase. I'd use these for the earth, right? But I use these ones for neutral or earth, or the thermoplastic ones. Thermoplastic ones, they look similar to these, but it's a harder material, right? Because what it is, when you use these ones, and with so many cables in one connector, if you don't get it connected properly, then you get friction. And if you ever come across friction in the neutral, these just melt. I've come across it where they've just melted and welded everything together. So I never use these for phase or neutral, just for earth. And if I can't get Wagos, I use these ones. Bakelite, tougher material, doesn't melt. Okay, just thought I'd let you know that. Look at all those cables. I've got to fit in there into a junction box, or and get it up into the ceiling. Not a lot of room. This is coming out, so by the time I cut that plasterboard to get the box up, oh man, this is aggravation. See how it goes. There you go, all in place. Working, everything good. Oh boy, that pull switch was a real task. I don't know what you guys would have done. So, like I said, I got them into the chop box, nice and tight, with a mixture of Wagos and those connectors that I showed you. And then got it all connected nice and firmly. It's working beautifully. That's it. But that was a task. So you young sparkies out there, when you're doing your rewires, never have so many cables at pull switch of all places. 5 neutrals, 4 lives, 2 switch lines, 5 earths. Because he must have forced that pull switch up. Because I don't see how you could get that in. He must have forced that up, and that's why something must have happened to the switch, because when you pulled it, it clicked, and then it clicked again. That was going to eventually go. So best if you change it now. Yeah. All right. Cool. Bye. I was just looking over at the fuse board there, sussing out how I'm going to bring the cables in. I think some of them I'll have to use stuffing glands and bring them at the top. But some of them I could bring from behind, I think. But I just noticed something I'm going to show you. That's one of the circuits in a connector block. I presume that should be in a proper junction box. So when I take this all down, because I think it comes from over there, and it also runs in this trunk in here. But obviously they had to do a joint. And that's just connectors, you can't do that. Connectors taped up. Should be in a proper junction box. So whenever I get this fuse board down, see what other wonders they've got. Hopefully it's not too many like that. So I'm just looking at this and I'm just thinking the best way, because I'm going to have to get a bit of board, try and get a bit of board across here for it to sit on properly, and get on with it. I'm not going to do that now anyway. I'll leave that. I'll come back on that. Okay. I'll keep you updated.